Hi, the topic of this video is cross products. So if you have two vectors, vector A with the components A1, A2 and A3, vector B with the components B1, B2 and B3, the cross product of these two vectors A cross B is going to be equal to the determinant of this matrix I, j and k, A1, A2, A3, B1, B2 and B3. Okay. Also, the magnitude of the cross product A cross B is equal to the magnitude of A times the magnitude of B times sine the angle between them. Theta is the angle between both vectors. So these are the two rules or definitions you need to know about cross products. Also, you need to know that A dotted with B is going to give us a scalar. A cross B is going to give us a vector. Alright. Also, you need to know that cross product only defined in 3D. Three-dimensional. So if you have two-dimensional vectors, you can't find their cross product. You can only find their dot product. Okay, so let's see a graphical representation of cross products. If this is vector A over here, and this is vector B, then A cross B is going to give us this vector over here, which is perpendicular to both vector A and vector B. And the way we figured out the direction is by using the right hand rule. So if you use your right hand, curl your fingers from the tail of vector A to the tail of vector B, your thumbs will be pointing upwards. So if this is your hand, you curl your fingers, your thumb will be pointing upwards. Okay, now B cross A will be pointing downwards. And again, the reason points downwards because of the right hand rule. Use your fingers, curl them from the tip of vector B to the tip of vector A, and see where your thumb points. Thumb will be pointing downwards. So this is how we find the direction of the cross product of two vectors. Now the magnitude of the cross product, so the magnitude of A cross B is equal to the area of the parallelogram, and that's the parallelogram defined by the two vectors. So if you see the parallelogram defined by these two vectors, it has the area. This is how we find the area, and you can make sense of this because we know that the magnitude of A cross B is equal to the magnitude of A times the magnitude of B times sine the included angle. If you think about this is a parallelogram, the area is just the base times the height. So if this is vector A, this is vector B, this side has magnitude A, which is the base, and the height will be over here. If this is angle theta between the two vectors, well, this is just the magnitude of B times sine theta. So it's just base times height. Alright. Let's actually have an example and see how to compute the cross products. Given vector U with the components 2, 1, 1, vector V with the components -4, 3 and 1, and want to find U crossed with V. Okay, so we're gonna use the formula I just gave you. The cross product of two vectors is equal to the determinant of this matrix over here. We always have I, j, and k. Gonna have the first vector 2, 1, 1. The second vector will be -4, 3 and 1. Okay, so let's actually compute this. It's gonna be I times 1 minus 3 minus j times, if you cross this is going to be 2 minus negative 4. So it's going to be 2 plus 4. Then plus k times, if you cross this and this, it's going to be 6 minus negative 4, which is 6 plus 4. So this is going to give us negative 2i minus 6j plus 10k, which is this vector, negative 2, negative 6, and 10. And that's the cross product of the two vectors. This is u cross v. So how can we verify this answer over here? Well, if you remember when we talked about dot products, we said that the dot product of any two perpendicular vectors is 0. And now we said that the cross product of two vectors is going to give us a third vector that's perpendicular to both vectors, which means this vector should be perpendicular to this vector and this vector. So if we do the dot product of this vector and one of these two vectors, we should be getting 0. So let's actually verify this. Verifying 2, 1, 1 dotted with negative 2, negative 6, and 10. We should get, this will be negative 4 minus 6 plus 10. Well, this is 0, which means this answer is correct. Okay. What else did I want to talk about? Yeah. Again, when we talked about dot products, we said whenever we think of an angle between two vectors, or we're interested in the angle between two vectors, we use dot products. So angle between two vectors, should immediately think of dot products. Well, you can also use the cross product to figure out the angle between two vectors. The thing is, cosine is an easier function to deal with than sine, because the cross product you have to use the sine, and dot product you have to use cosine. So here's the graph of the two functions. This will be cosine, this will be sine. So if you have cosine theta is equal to something, well, you can easily find this angle because you have a one-to-one function. Unlike sine, if you have sine theta is equal to some value, then you're trying to find what's the angle. Well, it could be either one of these two angles. And again, we're only concerned between angles that range from 0 to 180, because that's an angle between two vectors. So yeah, that's the reason we prefer using cosine, or using the dot products to figure out the angle between any two vectors. So we said that if two vectors are perpendicular, this means the dot product is equal to 0. Well, if two vectors are parallel, the cross product is equal to 0. And again, the cross product is only equal to 0 when the angle is either 0 or 180 degrees. Remember, the magnitude of A cross B is equal to the magnitude of A times the magnitude of B times sine theta. So if two vectors are parallel, like this, or the angle between them is either 0 or 180 degrees. And sine 0 is equal to 0, sine 180 is 0. So if two vectors are parallel, their cross product is equal to 0. I guess that's it. The next video I'm gonna be showing you a different way to compute cross products, and I'll also give you some of the properties you need to know about cross products. If you have any questions, please leave them down in the comment section below, and I'll be more than happy to answer them. Good luck.